Hello friends, good evening. Welcome to Eason Academy. We are discussing about controller programming as a part of embedded system programming. And now we are in session 2. In this session, we are going to discuss about a sample controller. Okay, so the reason was all the available controllers today in the microcontroller are all very complex. So we thought we'll take a very sample controller. We will design our own thing. Then you will understand what is that. Okay, so let me get into the board, try to discuss. See, this is a trick here. This is the trick here where with the people in the industry experience, we know exactly what is there in the industry. So what you have to learn. Learning is okay, but what industry wants has to be learned by you. That's a trick. At the same time, industry wants both. You have to know the latest, and you also want to learn the concepts, old one. How do I do both? That is the trick. So let us start using the same microcontroller. Okay, let us assume that I have a microcontroller with the 2 ports. I have microcontroller with 2 ports. Only 2 ports. Let's say this port number is 0x30. This is 0x31. This is in port. We assume, I'm just assuming that this is the input. I make this port as an output port. You understand now? This small microcontroller. I have an input port. We know that. Now, if I write a program, char star in, comma, char star out. I have 2 pointers. In equal to 0x30. This address I have given now. I say out is equal to 0x31. I put down. We put star out is equal to 0x01. This LED, if I connect a LED here, that LED will be on. Now, I wanted to make the LED blinking. So what I do here, while 1. See here, while 1. Right. Now I'll say that star out equal to 0x01. I make this guy as 1. Forget about the other pins. I'm not using them. I'm using only one LED. Okay. Let me make it as a different color. Let's say I make a red color. Now there's one LED. So what I do here is I write a small delay for I is equal to 0, I less than some 10,000, whatever it is, I plus plus. Am I right? Or I have a function called delay. Then I say star out is equal to 0x00. I off the LED. Then I put delay. Now what is happening? This while loop is constantly executing. The LED is blinking. Now I give you one important information. You compile the program. You compile this program and download it to the flash. Inside flash ROM. You download it now. Now, based on the number you are giving here, the delay function, let us say the delay is 1 second, assuming that the delay is 1 second. I have a function called delay. That will do for loop. Long I. For I is equal to 0, I less than some number, 1 lakh, I plus plus. So understand now, I create a delay now. So whenever I call the function, the delay will be executed. That's fine. This I put it inside the chip. But I tell you one thing, you are not supposed to change the program again. You have done only once, you have done it. Now I fix the number 1 lakh. How do I change the delay? Now I wanted to blink on every 2 seconds. I wanted to blink on every 3 seconds. 3 seconds on, 3 seconds off. But you are not supposed to change the program. Understand now? You are not supposed to change the program, but I want to change the LED's interval. Initially, I'm making it as a 1 second. Then I want to have a 2 seconds. And sometimes I want off. I want to make the LED itself off. Am I right? How do I do that? Am I right? How do I do that? But you are not supposed to change the program. Now we modify the program slightly. We modify the program slightly. See here, same program, while 1. I modify the same program. Now I do here star out equal to 1. I'll make it as a 1. The LED is on now. Now I made it on. But for example, I have a variable called X. I say X is equal to star in. X is equal to star in. For example, you connect all the pins to ground except this pin. Now I'll be reading, this is a bit 0, this is a bit 7. I'll be reading 0, 0, 0, 0, 1 to 1. Now I say that delay X. Then I say star out is equal to 0. I make it off. Then I call delay X. Then I put this. Go back. Sorry, I forgot this. Same thing, sorry. Delay X. Do you understand now? If you don't understand, let me know. If you don't understand this program, let me know. I do one thing. I'm going to read the pins input. Previously, I was doing everything only the program. Now I'm reading. This guy will take now int X, say char X, whatever it is. Because you said character here. This is also character, this is also character X. Now I'll do here for, sorry, while X. For I is equal to 0, I less than 10,000, whatever it is, I plus plus, X minus minus. Now if you put X is 1, the loop will be executed only one time. So 1 second delay. If you, for example, if you connect these 2 pins here, then 1, 1, it become 3. So now what will happen? X become 3. This guy will start executing 3 times. So you get 3 seconds delay on 3 seconds, off 3 seconds. Do you understand that? Is it clear? Let me know if you don't understand this. I'm doing a small change. I don't change the software now. Normally, when you have a delay, you change the time here. That's why now you understand. If you have to understand the controller, you should know this embedded programming. If you have not done a switch program or LED program, you will not understand this. That's the problem. Understand? Is it clear? So this input port, this one. Now what happened? Understand one more very important factor. Today you can buy a microcontroller And using your laptop, you can write the program, you compile it. After compilation, you download it. Now the code is into the ROM. But you can also make the ROM as secure. There's a fuse inside. If you make it secure, then what happened? Nobody can read the ROM, what is inside the ROM. Now the microcontroller will work because the microprocessor inside the microcontroller will read the code and execute. But you cannot, let's say I do that. I write the program and give it to you. You can use the microcontroller, but you cannot change the ROM, or you cannot read it, what is inside. That means that this you cannot copy the same IC to one more. It's not possible. This is called security fuse. If you blow the security fuse, nobody can read the ROM. So what I do is I make this about 100 ICs. I buy 100 microcontroller. I program everything here and sell it to market. For you, the advantage is you have to buy this, my IC. You buy my IC. You have a microcontroller. This is your microcontroller. Maybe 8051, whatever it is. That 8-bit, a port, let's say port A or port 0, whatever it is. You connect it to my controller, is having an input. And connect the LED here. Understand now here? This is what my LED controller. Manufactured by Eastern, assuming. Eastern manufactured this and give it to you. You bought it. Now what you have done, you use this on your circuit and you use 8051. This is called LED controller or LED blink controller. Now this program, what is written here, you cannot change it. That's it. That program is fixed. This program is fixed. You cannot change it. But you can write a program here. Here you can write a program as star out. Out is equal to 0x80, example. Now star out is equal to 0x05. Now you do, let's say 5. Let's say 5. Easy. If you say 5, 0, 0, 0, 0, 0, 1, 0, 1, it goes here. Whereas this program always read the port. Now 5 is coming. What happened? LED will be on by 5 seconds, off by 5 seconds. If you write here 100, then the LED will become 100 second on, 100 second off. See that you can make him to do that. You can do your own activity. The LED will be done by this guy. Who? That Eastern will start doing the LED blinking. You can do your own activity. Is it clear or not? Now I built my own controller, LED controller, which does only blinking. For that blinking, you are giving a command from your microcontroller. This program you can modify anything as you wish.
Sir?
Yeah.
Sir, for our microcontroller, for the same example I'm taking, for 8051, in place of 8051, if we use ASIC, so we can't modify our program also, no, sir? It is fixed, right?
Yeah, it's fixed. If you use a, no, wait. 8051 itself is a ASIC. 8051 itself is ASIC. I know that you are. It's a very, but you are very clear. Everybody will tend to behave as if they understand, but nobody understood. What you are confusing is very clear. Understand? This is a very tricky area to understand. But give me some time, you will understand. You keep on asking. See, ASIC is a fixed IC. Your 8051 is a microcontroller built using ASIC. But I can also build a microcontroller using FPGA. So 8051 can be built using ASIC technology or FPGA technology. You can do anyway. Understand? So don't get confused between 8051 and ASIC and FPGA. These two are implementation. These two are functionality. I use gates to build 8051. How the gates are going to be connected? In the ASIC, it makes a fixed connection. In the FPGA, I give you the flexible connection. That's the only thing. But 8051 uses gates and connections. That connection is called circuit. Understand that?
My question is that for internal modifications,
you can do that. You can do that. If you put a 8051 here on a ASIC, I can do that. ASIC, see, ASIC does not mean you cannot change it. I cannot change the connection. Please understand, ASIC does not mean that it cannot be changed. The ASIC also, I can make an ASIC which changes the timing as you wish.
Okay.
What ASIC is a very big question for you. ASIC is the implementation. What ASIC, what functionality you are building is a very important thing.
Okay.
That is a trick. I cannot just say that, oh, because you're using ASIC, you cannot change it. No, that doesn't mean that. ASIC is only an implementation which can be changed. You can have other inputs. The ASIC, for example, take the input from outside. It can change the output here. That you cannot say that. So, understand the difference between microcontroller and controller. But one problem here. I have 8-bit. I have 8-bit. If I have a 8-bit, I can change from 0 to 255. 0 means off. 1 means 1 second on, 1 second off. 2 means 2 seconds off and 2 seconds on. 255 means 255 seconds on, 250 seconds off. That's it. The problem is I cannot. If I want 1.5 seconds on 1.5 seconds off, it's not possible. You understand now? You understand now? 1.5 seconds on 1.5 seconds off. Because you can give either 1 or 2. You cannot give 1.5. So this is a drawback of this controller. Whereas if you are writing your own program, you can change it. You can change the for loop time. You can able to change it. That's a flexibility you have it. But if you use the controller, whatever they have designed, only you can use it. Or you have to go and buy another controller. You can buy another controller. That controller will tell you that you can do that. If you say that controller will say that if it's a 1 means 0.1 second, 2 means 0.2 seconds, 5 means 0.5 seconds, 15 means 1.5 seconds. But you can give 255 means 25.5 seconds. You cannot go more than that. See, understand, there are 2 types of controllers available. There are 2 types, controller 1, controller 2. In controller 1, if I say that 1 to 255 seconds, 0.1 second to 25.5 seconds, you can choose one of them. If you say that, if you choose this, advantage is maximum 255. This is advantage. But disadvantage, 1 second resolution. 1 second resolution. That is only possible. Whereas in this case, The second case, controller 1. This is controller 1. The controller 2, you have advantage. What is advantage? 0.1 second resolution. I can increment by 0.1. If you want to blink the LED at every 0.5 seconds, that is possible. But disadvantage is maximum is 25.5 seconds. You understand? You have to always understand the advantage and disadvantage of these things. Otherwise, you cannot buy it. You buy this. Now, let us assume that I want to have a 0.1 second resolution. Also, I want to have a more than 255, 25.5. I want about 400. Then you have to buy another controller. That controller is having a 2 registers, 8-bit. That is 716-bit. That means that this guy is having an address of 0x30. This guy could be having 0x31. You have two ports. You need to have a connector to two of them. You understand now? This is what these are also called. These are also called registers. This is the only way you communicate to the guy. How they do it is controllers like this. Functionality can be defined by the manufacturer. Let us assume that I have a controller. I have a controller. The controller is having so many registers. Let's say I have 8 registers. 0, 1, 2, 3, 4, 5, 6, 7. And I have a microprocessor. Understand? I have a microprocessor. This guy is having a 16 address lines and 1 write and a read and data line 8-bit. So data is connected to data. Fine. It goes fine. And read is going to read kite. Write is going to write kite. They're all fine. But I have 8 registers. So they have 3 address lines. A0, A1, A2. 2 power 3 means 8. Now, this guy is having 16 address line. The 16 address line, how do we do that is, if you have a 16 address line, let us say I take about 80. 800. That means that 8 means 1000. 0 means 0000. I have 16 lines, but 3 lines I connect them directly. You don't use the 3 lines which are going here. I use the remaining, how many lines? 11 lines. I create a combination logic. A15 to A4. This is A3, sorry. Understand now where the combination logic is used. Now, this guy is giving a output signal called select that I connect to this guy. This is called chip select. You understand? Now, when chip select is 1, then only this guy will accept your read and write. Otherwise, he will not accept. And this is the way the controllers are designed. So every controller is having so many registers. Based on the number of registers, you will have so many addresses. If you have only 4, I'll have only A0 and A1. If you have 16, I'll have A0, A1, A2, A3. Now, this 8000 is called base address. Understand? Very important. It's called base address. Whenever you access a controller, you should know what is the base address of the controller. And when you want to write it to the registers based on the functionality, if the manufacturer tells you that, hey, in 3, if you write, I will blink the LED. And if you write 0 on the 4th one, I will stop the LED. If you put on 5, I will restart the blinking. Understand these things. And this is called on time. This is called off time. For example, I want to on for 1 second, off for 0.5 seconds. I can change it. So this is what written in every controllers I'll show you that right now. Temporarily, after this, I'll show you. Please understand the base address. So every controller is having a base address. And this 0 to 7 is called offset. So yeah, address of register. For example, I may be having the same LED controller 5 in my box. I may be having a 5. For example, I may be having see here, I have a 1, 2, 3 LED controllers. 1 LED connected here. 1 LED connected here. 1 LED connected here. Understand? So there are 3 LEDs. This is red. This is blue. So green and blue. Now this guy's base address is 8,000. This guy base address is 9,000. This guy base address is 7,000. Assuming. Now these are all called base address. I will show you the same thing in the ARM. Then you will understand. If you go to the ARM, then you will understand why I'm showing you this. Don't worry. It will be very confusion, but you will start getting into that. You don't underestimate your brain. Your brain is very powerful. You see here, I have shown you that this guy has so many controllers. Am I right? This chip. But if you come down here, let's start with a simple controller. Starting with that, why do you have a complex one? See memory mapping. If you click the memory mapping, see here, I'll make it bigger one. Sorry, I'll make it a bigger one. This is what I want you to learn. See here, every controller, whether it's a timer 1 or ADC or port or everything, they have this address. This is called base address. For example, I have a timer. Am I right? There's a timer 1. Then in the timer 1, I have the base address. See, I2C. UART. Everything is having a base address. But this tells you that, understand one thing. Both the I2C controllers are same. But only thing is, this controller have a different base. This controller is having different base. Now, I want to know what is the offset. Then I have to go to another data sheet. There's one more data sheet called, let me check whether I have downloaded or not. Please. See here, this is what the data reference manual, they're called, this is the program manual, sorry, I should have arranged it correctly.
Sir, for every controller, sir.
Yeah.
Sir, for every controller, we have this sheets, right? They
correct.
Will show each and
yeah. That's why I'm trying to teach you that how to have a common one. Understand? That is what the trick. Okay. That is a way you should do the thing. You cannot, you should not worry about this. If you get the data sheet, you should know what to look for and what to change. That's the way you should behave. Don't try to get into the too much details of that. Now let us take the other one itself. Some other microcontroller reference sheet. It's a mistake, not organizing it properly. See, they call reference manual. Please understand, don't get confused between data sheet and the data sheet is for hardware. all the memory map, everything. When you are trying to program, you come here. If you get to all the controllers are available here. Okay, let us take the GPIO, for example. If you take a GPIO and registers, you have to go here. See here, na? See, I'll make it bigger one, then you will understand. These are the tricks. You should understand what I'm explaining now. You see here, na? This key is called offset. And he also says that port A to IJK. Why it is? Come here. If you come here, you go to the memory mapping. You come to the memory mapping side now. They mentioned here for each and every ports. See that they given you for every port GPIO I, GPIO A, for everything this address. So this guy is having so many controllers, but the data sheets will refer for you only one port, offset 0. Then you should know that for each port, how do you do that? See, offset 0, offset 4, offset 8, like that. So please understand, offset tells you now what is the meaning of this. I'll once again tell you, you might have slightly got confused. See, now I have a LED controller. Sorry, I have not started this board. Maybe a little bit confusing, but you will understand at the end of it. Don't, just because of confusion, don't leave it. This is all very critical point. You don't get it anywhere. This is all after my so many years of experience. I'm putting it on this. Now you have a LED controller, which has 8 registers, 0 to 7. Now, this controls only one LED. But then the manufacturer thought, the product, hey, we need the functionality for 3 LEDs. If the red is blinking means there is one error. If a blue is blinking means there's a different error. Green is blinking means different error. So what we did, the hardware person has put 3 controllers. But how do I differentiate? As a software person, how do I differentiate all the 3? It's a base address, 8,000, 9,000, 7,000. It's a base address. If I write a program, char star X, so I start what you call timer, or LED, star LED 1, star LED 2, star LED 3. See that? I have LED 1, LED 2, LED 3. I put here LED 1 is equal to 8,000. LED 2 is equal to 9,000. LED 3 is equal to 7,000. But now it's a trick. This guy is 7,000, 9,000. This guy is 8,000. Now I say that star LED 1 plus offset 3 is offset equal to some 0x01. So this LED is going to blink out every 1 second, red. Now I say that star LED 2 plus 3 equal to 0x05. Now LED 2 is 9,000. I write here. I have written here 1. Here I am writing 3. So sorry, 5. Now this LED will blink every 5 seconds. Now I say star LED 3 plus 5 equal to 0x05 or whatever it is. This game will do some other functionality because I'm writing on different register offset. So this is called base address. This is called offset. Normally in the interviews, People will ask you this, what is base address, what is offset and everything. You need to know these things. Also, while programming, you have to know all these things. This is what another trick. They give you the file called .h file, header file. In that, if you take stm32.header file, all the registers offsets are defined like hash defined. A LED on, 1. Hash defined, LED off, other one. Now I can use that definition, LED on, LED off here. I can do here LED 1 plus that offset, so that I'll be able to control it. So these are all available in the .h files. But initially don't do that. Initially start creating your own .h file. As I told you that you need to first understand the basic principles of how this offset and base work. Not particular register, particular controller. I am using 3 controllers. Yeah, all are same controller since they have a same offset. Base addresses are for controllers, not for register. The offset is for the register. So base address plus offset gives you the particular register. Now it's fine. Now, since you've asked now, I'll explain to you now. See, this is 7,000, 8,000. This is 9,000, 7,000. Now, if I say that hash define LED 1, 0x 8,000. Hash define LED 2, 0x 9,000. Hash define LED 3, 0x 7,000. If I say that hash define on off control, or let's say on 0, hash define off 1, hash define on delay 2, hash define off delay. Understand now? Now if I say that star LED 1 plus on equal to 1, that means that, you know what I'm writing now? LED 1 is what? 8,000. 8,000 is equal to star 8,000 plus on is 0. So at 8,000, I'm writing what value? 1. That means in this case, I'm on the LED. Now I say star LED 2 plus off equal to 1. That means that LED 2 is 9,000. I add 9,000 plus 1. I'm going to write here, first register. If I say here star LED plus on delay, LED 3. LED 3 is how much? 7,000. 7,000 plus on delay is 2. So 7,002 I write here. So you can select which controller, what register. This is what the exact programming practice used in the industry. Understand? This is the exact programming practice used in industry. These things are normally given by the company. You do not have to fill these things. These .h files are given by the company. But initially, to understand, you create your own .h files.
Sir, based on the registers value, different operations are performed.
Exactly. That we will see that next class. We are going to take a LCD controller, this one, a real LCD controller. We will write to the registers. We will see that on the thing what is happening. This is my own sample controller, which I'm trying to explain to you that how the things are designed. Now, if you understand this, next class, we will take the LCD. Then we will take about timer. Understand? That's the way we go about it. But this class, you have to repeatedly watch the video, this class. Then only you will understand. And this is what exactly, 1 minute, I'll show you once again. That is what this,
Sir,
once you understand
sir.
this, yeah.
Sir, what is the offset value for that program, sir?
Which program?
Just now you wrote hash define on delay, off delay. For that, what is the offset value, sir?
Yeah, here, the bottom one is offset. I'll show you that, sorry. So, see, base address plus offset. These are all offset.
Sir, 0, 1, 2, 3 are registers on
Yeah.
one. On a, okay, got it, sir. Got it.
This is register. And what I'm writing is a value. This is the,
Got it.
so this is base address. This is offset. This is value. Based on the value, that game will behave. That's the trick. Let me show once again the control, because that you have to always attach with the real life. Then you have to start programming. That's why I wanted. That's the, see here, the data sheet which I have shown now. See that this case is having a, if other one means very easy here. That's why this one I showed you. See here, every controller is having a offset. So you cannot mistakenly program it. Whichever controller you want to take that, you have to take the this one, base address. This is defined by the controller chip, the manufacturer. The ST Micro has designed this. If you go to the different manufacturer, different controller, you see here. Let us take port A. What is address? 4001 0C00. Understand? This is address. Let me make it big. Then you'll know. See, port A. Am I right? The port A address is this one. 4001 800. On same ST Micro, Cortex 103. Now let us see that 407. What is address? The port A. See here, the address is different. Let's make it big. See, GPIO0 is, what is address now? 400200. Please, the same company, between two controllers, the base address is different. That's why you have to know that. There's no way that. So if you write the same program here, that will not work. If you copy the program from this 103 to 407, that will not work. But once again, I'm telling you that these are all not as complex as you think. Since you have not written, you are trying to watch the swimming by the thing. Even next class, when it's LCD, you should start writing the program. Then you will know that. If you don't write a program, you will never know that. I'll bet that. These are all not knowledge anymore. Yeah.
Sir, this is for this 0x4002 00003FF. This is base address, right?
Correct. Offset is here. This is base address. The offset is here. See here. The offset here, what they said. Every offset, what they have written here is, they mentioned that what functionality. See, offset 14. Offset 18. See that? Here in this manual, they will not mention about what do you call base address, because this controller is common for all the GPIOs A to K, whatever you can write it, but only base address will change. If you write 18, it will not. You have to add the 18 with the base address. Then only you select the right controller.
Okay, sir.
So this is a very, very nice thing, but start practicing. It's very important. Without this, you cannot go to the next stage.
Sir, these address and all are defined in a function, sir.
Which one?
I mean, sir, in normally in Arduino we have inbuilt functions, sir.
Yeah, they have. That is the reason people say that if you use the Arduino functions, you are not getting recruited by the companies because you don't know all these things.
I mean, sir, when we give a pin digital like 1, so it will call the base address.
Yeah, exactly the same thing. That's why
So
industry don't encourage you to use Arduino. Because without knowing anything, you use to call the function.
Okay.
That's the thing. They want you to know all these things. These things will be asked in the interviews. Where if you tell them very clearly, and if you know how to use the function, they will take you. They see the using your function is very, very important. But after this, see, I told you now, the thing is very clear. The industry wants C programming for all the embedded people, but they want the C programmer of the ECE background, not the computer science background. You understand? Otherwise, every C programmer will go to embedded now. Why they don't? That is because industry wants C programmers plus electronics background. That's a very unfortunate. They don't teach these all. See, this is what the real life which is going to give you this. I think not the depreciation layer or not the feedback controller. Nothing. Class A, Class B, Class C amplifier. They will not get you job because they're all gone. They are all 1980 syllabus. But this is the one which is going to give you the job. This is what exactly I'm comparing you the controller used by the industry. Tomorrow you take this, you will understand that. How many pages? You see that it's remarkable. It's about 1,751 pages. But you can glance through in one day. If you know my methodology, you will glance through in one day. You do not have to read. Understand? So why I've explained this was, you can have one controller with more registers, and you can able to duplicate the same thing with multiple registers. And there are only few controllers are very important. That if you know all the controllers, timer, first of all, LCD, I2C, SPI, RTC, like that. If you know them, industry will take you. Nothing more than that.
Sir.
Yeah.
Sir, what are the important things we need to concentrate in a data sheet, sir? Apart of reading all.
Yeah, you are right. That I'll show you now. Right now, I'll show you a minute. In the data sheet, you should look for. First thing is when you get a data sheet, you open a data sheet. You have to understand the first one. Let me make it bigger one. This is very important. First page. That is, every line you should understand. What is this you should understand. Okay, what are the interfaces? Then you should know that what is the speed, what is the performance, how much is the memory. Okay, then what is the sleep mode and the stop mode, and how many ADCs are there, how many DMA channels. Okay, how many IO operation. You have to understand all of them. Then you go here and click the ordering information. There is something called ordering information. There you will know that what are all available. 36 pin is available, 48 pin is available. What are the packages available? BGA, UFPGA, UFPGA, LQFTP, and UFQ-FUN. That's the packages. What is the temperature variance? This is called ordering information. Then revision history. When is the latest date? They have modified. July. And then go back, beginning. This is very important. Introduction and description. You have to read the description very thoroughly. This is the one which describes the chip functionality. Okay. Then the overview will tell you that what are the different chips. Same chip with different functionality. Then pinouts and all, forget it, not required. You do not have to get confused with the pinouts and all. Memory mapping. That's it. As a software person, you have to go. If you want to have a hardware design, you have to know about all these things, electrical characteristics, package information. These are for board designers. This is for PCB designer. This package information will be used for PCB designer. And the electrical characteristics is used by the our hardware engineer. They know that how much is the current, how much is the power, everything. See, they tell you how much current each pin takes, each IC takes, all those information. And so memory mapping. See, description, introduction, memory mapping, and ordering information. What are the size? What are the ports are available? Understand? Nothing else. This is enough. You'll be able to understand the chip. Basically, for initial days, learn first one. The first page and description, try to understand. Then memory map. Enough. Initial days, that is enough. And in the programming, you start one by one all the controllers, timer, that we'll discuss from next class onwards. How do we do that? Okay, so I think I've fairly won't watch the video a few times. I think I fairly explained about what is the controller and how the controller works. But next class onwards, we'll take the real examples: LCD controller, timer controller. There are about thousands of controllers. We'll take only few of them. And ADC controller, DAC controller, PWM controller. All these things we will discuss. Okay. We'll discuss few badly used all things. Understand? If you have any more doubts, you can ask me.